Okay, and okay, I'm going to unmute you now. And who wants to go first in terms of questions? We are in the question and answer session now. And I will put it back on speaker mode. Okay, and Paul, we can hear you again. Let me see.
Yeah, if they need me to show anything from the slides.
Yeah, well, let me see. Erica said Jeremy wanted to ask some questions. Jeremy? Oops, yeah, there you go. Sorry, Jeremy, hit unmute again.
Mm-hmm.
There we go.
Yeah.
All right there. Yeah, we have a live audience, 143 people watching. So out there. So this is cool. This is one of our best ones yet, man. Thank you so much for an excellent presentation, Paul. I have your book right here. Let me get my video on here too, so I can see. I have your book right here. I'm particularly liked chapters. The chapters on the microwave phase conjugation and what was it? Chapters
Project Skyvault.
Yeah, Project 5, 6, and 7 and 8. Oh, 8 and 8. Sorry. Yeah, and the microwave phase conjugation and Project Skyvault. And it's unfortunate you even went over, but you didn't even have time to get to too much of that in detail on too much of that stuff. Because I've been researching a lot of stuff on phase conjugate mirrors. And barium titanate crystals and how phase conjugation works and barium titanate crystals and four-wave mixing and some of these other schemes that you had mentioned or talked about in that book. And I was curious where you had come across that awesome information
For this Skyvault?
Yeah.
I was at Bob Brown's UFO conference and presenting about actually a different topic about Earth changes. And a fellow approached me after the conference and said he'd like to be in touch and gave me his email address and phone number and so on. So after the conference, after I went home, I contacted him, and apparently his boss once worked on that project and sort of spilled some of the beans to him. And that's how he knew about it. And he passed all of what he had on to me. He also got his boss to put him in touch with a fellow who was still working on the project at that time. And he had a few letter exchanges with that fellow. And taking all their information that he passed on to me, I was able to sort of reverse engineer the whole project and use his phase conjugation at microwave levels. There's a lot of articles on phase conjugation used for optics, but even Scientific American talks about that. But there was like a blackout, news blackout on microwave use of phase conjugation. All that was done by the military. You found one patent on it by Hughes Aircraft. Hughes was one of the main developers of all that stuff. And they were, of course, working in anti-gravity. So that's how I got tipped off about it.
Interesting. I had another question about the models. You had mentioned that you had an assistant or someone another scientist you were working with named Brendan. I didn't catch his last name. The one that had built those models for you.
We have a group. It's called the Model G Vortical Motion Group. Brendan might be attending. He may be one of the attendees here.
Oh, and do you have any information that you could share on how other people could learn about that, Paul?
Yeah, we're looking for other people who have experience in computer modeling. We have a Facebook page, and you could send an email to me, and I could put you in touch with Brendan. So we meet every Sunday for an hour using Zoom, and doing a lot of interesting things. We're trying to simulate the vortical motion of the particle to hopefully have a model of spin. So that would be a great step forward if we could show that.
And if I could jump in really quick, I'm sorry. Your email is ethericgate@gmail.com. I'm going to paste that in chat too. But so for anybody on YouTube, it's ethericgate, ETHERIC, ethericgate@gmail.com. My apologies. Okay, Jeremy, I'm sorry. Go ahead, sir.
Yeah, so I'm super interested in your modeling group. I want to learn. I have a couple people who are computer scientists and work with computer modeling and stuff. And we were working with some of that Wolframs, the hypergraphs and stuff recently. And I think that some of those people would be interested in your model, because you showed briefly it was a graph model, and it was an iterating function or a recursive function, and very similar to what Wolfram posits for what he would expect to be the generated source code of the universe. So I would certainly like to try that image and that graphic that you came up with and I'm struggling to wrap my head around what the primes mean, and the G and the Y and the X and all that. So I'd like to learn more about that and see in computer modeling.
Yeah, Wolfram he put out some papers where he was saying that the future of physics would be modeling, and that it's possible to model a universe basically using computer modeling to hopefully model physical phenomena like particles, so on. I don't know if he actually mentioned particles, but he's basically, what he was saying is the approach that we've been using. I started doing this back in the 70s. And he published his paper around 2000 or so. We actually used his program Mathematica as the platform to do our initial simulations in 2010. Now we're using other programs.
It's powerful software.
Yeah, maybe if people with Wolfram, with his company are interested, they're welcome too. This is amazing effort to move forward. It's very exciting.
Okay. Now let me go next to Marco. Marco, this was actually a few minutes ago now. Marco, are you still there? Yeah.
Yes.
Okay. Go ahead, sir.
Yes. Sorry for my pronunciation. You said that the thrust that produces the Biffid-Brown effect is of gravitational origin, but both NASA and other scientists have tried to reproduce this effect in a vacuum, but without any results. So if this thrust is a gravitational pulse, why does an asymmetric capacitor not produce any force in the vacuum? Thanks.
Well, we have Brown's work. He did his experiments in a vacuum, and he was getting thrust, pinwheel sort of thing going around. Brown's experiments have been duplicated by Cornell and published in referee journals, so it pretty well establishes that it's real. They violate Newton's third law. He mentions that in the article. So it doesn't mean just because people fail in the experiment that it doesn't work the way Brown was talking about.
Let me go next to Michael Boyd, who has some questions. And thank you. I should apologize for jumping around. We've got a lot of folks on the call today. So, but Michael, sir.
Hello. Paul, I'm Michael Boyd, and my curiosity is about space-time metric engineering, and it sounds like you're using the word ether and vacuum energy interchangeably. Is that true?
Yeah, well, instead of a space-time concept, which I feel has been disproven, it's better to talk in terms of ether. Take the red pill instead of the blue pill.
So you're saying ether and vacuum energy are not the same phenomena?
Well, they're differently construed. First you have to define what you mean by vacuum energy, and you mean
So let me give a shot at vacuum
in
energy.
0-point fluctuations. Is that what you're talking about?
0-point
Oh, okay.
fluctuation, the virtual pairs. That
Yeah,
kind of stuff.
actually, in subquantum kinetics, the energy of what you call it, you have to use a different word from energy because you're dealing at subquantum level, where energy is a quantum phenomenon. You have the subquantum flux, and you have tremendous action, if you want to call it, going on, transmuting the ether, and that's what sustains our physical universe. The actual pulsations that emerge that we would call 0-point energy, they're little fluctuations of the ether. They are also predicted to be there, but not in the same way that physics says. Whereas physics has entire quantum size fluctuations of like equal in mass to a particle, going both particle and antiparticle, and then suddenly disappearing. In subquantum kinetics, that is a single fluctuation. That's not with a negative aspect. It's real. It's like a virtual, like electric. Think of electric noise in the ether, and most of them are below the level that would nucleate a particle. They're so small. But if you wait long enough, you get a very large one. And if the ether is fertile in that region, in other words, there's a G well or G low G potential there, it will nucleate a particle.
Okay, would you consider yourself knowledgeable about semiconductor physics?
Not that much.
Do you understand?
I'm not in electrical engineering that much,
Okay, would you understand the concept of what's called an energy band gap in a semiconductor?
Okay, somewhat, yeah.
Would you consider the ether to have a band gap like a semiconductor?
Okay, I guess I don't know well enough the concept to be able to answer the question. Band gap, so energy doesn't, that it needs past a certain threshold in order to have an effect? Is that what you're
Yeah, well,
saying?
it's sort of like in electrons, you would think of like the valence band versus the conduction band electron. So in the valence band, the electron doesn't, it's not free. But when you go to the conduction band, for example, like in a material like a metal, it's called a free electron. So you can like see the little shininess on the surface of the metal because the electrons are free. They're not connected. They're not bound to an atom. So, and the change in the energy between the valence band and the conduction band, that's called the band gap. And every material has a band gap. For example, silicon has a 1.1 EV band gap, and carbon has a 5.5 EV band gap.
We haven't developed subquantum kinetics to the point of applying to material science like that. That's something hopefully people will go into the framework of the ether physics of subquantum kinetics and then start applying to these other areas. We need people to get involved in it, really.
Yeah. So let me go next to Pablo. And Pablo, are you there, sir?
Yes. Yes.
Yeah. And can you start your video, Pablo, if possible?
Do you hear me?
Do we have any questions relating to the patents, the Pais patents at all, or these are all on other topics?
Yes. Do you think that the Pais patents work if they are compatible with the subquantum kinetics model?
Yeah, that's what I was trying to show you with the paper I wrote in 1985. I actually anticipated what they're doing 30 years before they published their patent. And it's all based on Brown and Bonson's work. I certainly believe that they do what they say. And that's probably what we're seeing. A lot of these UFOs, like what was it called? From the gun camera pictures the Navy released. those could be ours, you know.
Okay, I'm sorry. I'm meeting Pablo's getting some background noise also. So, and Pablo had also wanted to know more about your website. And again, I can put etheric Stargate, I believe that's, yeah, etheric.com. Sorry. And I will paste that into chat. But again, anybody listening, it's etheric.com. And Jonathan Lane had a question about the patents also. Sir?
Yeah, so got a sort of a two-part question. The first part is related to the patents. So when it comes to the way that the craft are supposed to produce lift, how is this supposed to work outside of a planetary gravity field, or would it be limited to repelling the sun's gravitational field, which at 1 AU is only about 6 millig's?
No, it would work everywhere. Earth's atmosphere, outside the Earth's atmosphere, out in outer space away from the sun, because you're generating your own gravity field around your craft.
All right. And my other question was about the mechanism for the way the inertial isolation works. I know we've got Mike McCullough on the call with us, and I've been following his work on quantized inertia. And the way you're describing the inertial isolation from the outside world sounds a lot like a Rindler horizon from his work. So do you think those are the same concept, or is there something else going on?
Yeah, well, it'd be good to interface with him and find out if there's a connection. Yeah, I don't know that framework that you're talking about, but basically gravity, you're not affected by the gravity outside your craft, like the Earth's gravity field, the sun's gravity field, because those are all geon fluxes are involved, and you're repelling those geons. They don't flow through the craft, they flow around it. So they don't affect the craft at all. All that you have as your basis is the positive gravitationally attractive floor and ceiling of your craft. That's your reference point.
Okay, that covers it. Thank you.
Thank you, Jonathan. Okay, so I had one more from Pablo, and he had asked me to ask this for him because again, he's having some background noise. He's wondering if there's a simple experiment that's kind of, I guess, a recommended experiment to kind of prove the subquantum kinetics model for generating artificial gravitational effects. And so I think what he's kind of shooting for is maybe something that people could try and construct on their own. Wouldn't necessarily fly or lift, right? But enough to kind of demonstrate an effect and help prove the model, so to speak.
Well, like Brown's work, I consider is the experimental evidence that supports that. And I cited his work, Brown's work, in my first publication of subquantum kinetics, that here is what subquantum kinetics was saying for gravity polarity being associated with electric charge polarity, electron versus proton, and that supports this. Here's experimental evidence.
Oh, wonderful. Thank you. Let me go back to Jeremy Reese. And again, Paul, I hope I'm not jumping around too fast. Are you doing okay so far?
Who, me?
Yeah. I know I'm throwing a lot of different folks at you. So
yeah, no, that's okay.
Oh, okay. Let me go back to Jeremy Reese then, sir.
Hey, Paul. I wanted to ask another question about the Pais patents and some of the physics that's going on there, according to your model, and then some of the, again, physics language that I've run into in my research into how this stuff kind of potentially works. Have you ever heard of a polariton or polariton condensate? You'd mentioned the soliton models and some of these things, but I was wondering if you ever heard of polaritons, surface plasmon polaritons, and what are called Zenith Summerfield waves or surface plasmon polaritons.
No.
Well, it's very interesting. I think it might be, I found a lot of stuff in the academic literature related to this. and I think it might be related to what you have going on there. And you have this model where it's vibrating. You have a mechanical vibration plus a coupling of electromagnetic fields and light, essentially. And there's a lot of interesting papers on light matter coupling and with light matter Higgs coupling as well.
Well, the mechanical vibration you're converting to electric pulsation. It's the main thing. It's electric waves you're putting out.
And those are far field rather than near field, because I know there's we talk a lot about the waves that are being put out and what their function is.
The longitudinal waves, no magnetic component necessarily. The beam generator that the Navy has they're spinning it that's the only way they use the magnetic field, is to confine the beam. But the waves themselves are electrogravitic, repulsive. And so the vibration they only use because with piezoelectric crystals, vibration is converted to electric, and you charge the whole thing up to extremely high potentials, and you're creating oscillations of electric potential on the surface. So when they say about the vibrations not affecting the inside of the craft in their patent to insulate it somehow, they don't want people to be affected, I guess, was from the actual physical vibrations that might be going on there.
And why do you think that the Navy let those patents out? Why do you think that they allowed that to like leak and get out to the public?
They're not leaking. They're doing it purposely as part of disclosure. And I met with people at the U.S. Space Command. Actually, the same year the first of those came out, but it was right before. And they were telling me about this new interest for disclosure, that they feel we can't go on continually having everything in the black world. The public needs to know what they've been funding, and that's why they create the Space Force. Eventually, the Space Force was created. And ideally in the future, those projects, which are black projects, would be run through the Space Force. And we haven't begun to see that it's just an entirely new world that's going to be out there for us when they start disclosing. The government will be disclosing free energy machines and med beds and anti-gravity craft. All this stuff is being disclosed. And so this is one example of their disclosure, was these crafts. But it's very old technology for them. They're not losing anything. It's at least 50 years old.
Paul, let me go next to Bill Alec. Bill? Let me see if Bill's, yeah, there he is. Let me ask you to unmute. Bill, you had a question, sir? There we go.
Can you hear me now?
Perfect,
Yes.
sir.
Yeah, hi, Paul. I've been doing a lot of work with Tom Bearden's analysis of scalar wave theory. And I'm working with these converging fields and transformers in a resonant mode connected up to a capacitor. And I'm seeing this strange wave that comes up during resonance. When you adjust the frequency on these transformers to its resonant mode here, I'm seeing this, this strange wave that pops up. Now, Tom calls it a scalar wave, but he also calls it a local gravitational wave as well. And you have to use, you can't use normal heaviside Maxwell electromagnetics.
No, those aren't magnetic wave, electromagnetic. They're scalar waves. Yeah,
it's basically empty. There's no solution for that.
Well, these appear in space, right? Is that what you mean? There's no charges or anything associated with them?
As an electric current. Okay. So I supply a steady state AC voltage to this transformer, but the electric current, I see this strange wave occurring at the at resonance, and it turns out that if I use Tom Bearden's solution of quaternion math, that the scalar component comes up. Okay, and there's a solution to it as a sine squared plus the zero vector is what Tom Bearden calls it, the scalar wave.
I would say you're producing something like virtual charge or virtual gravity. In other words, fields that aren't associated with matter in any way, but you're generating them as if you can generate very high potentials, plus and minus, right in the air. I've done it myself with a pulsating effect with a phase conjugation apparatus. And you get huge long sparks jumping in the air. And Tesla was experiencing those phenomena. So those are, I believe, virtual charges, a plus and minus that you create. Maybe
Wonderful.
That's something that can explain what you're doing.
Thank you, Paul. Let me go next to Vlad. Let me ask this on his behalf. He wanted me to ask if you could comment on John Searle's work and the claims of the anti-gravity effects in the SEG. I think you already talked a little bit about that.
Only that a lot of people have tried to duplicate his work. There was a Russian group and they weren't successful from what I understand. There was a group in Eastern US that I guess they were working with Searle and they were getting close to something. I haven't heard if they were successful. But I think in principle it's possible, and I have a chapter on that in my book.
You know, and also if I could ask on behalf of Morgan Lynch had asked, or actually Morgan, would you like to ask? I think he was asking, let me ask him to unmute there. I think he was asking if Beefield-Brown was, or sorry, if Pais' work was based on Beefield-Brown.
Oh, definitely. Yeah. And Bonson's work.
Okay. And
Bonson actually even stated in his laboratory notebook, he felt he was charging the ether around the craft, and it involved a resonance phenomenon.
Can I ask a short follow-up question?
Yeah, go for it.
Can you turn up your volume?
I can speak louder. I don't know if my volume is working.
That's perfect. That's perfect.
Okay, I'll speak louder. Okay, so one of the reasons why I wanted to ask this question, also, by the way, thank you for an excellent talk. So in terms of the relationship between Bifield-Brown and what Pais is doing, it's the couplings in these things, because Bifield-Brown is purely an electromagnetic effect, and so far as I understand, what Pais is doing. Electrogravitic effect, and then what Pais is doing is this conversion of electromagnetic radiation to gravitational radiation, which reduces the mass via the Gertzenstein mechanism. So he uses his...
He's trying to vibrate the piezoelectric, so you can use probably EM microwaves to excite the piezoelectric. But the piezoelectric it's a resonant cavity, so the piezoelectric would be going radially. And that would be producing actual scalar waves. It would involve magnetism of what's actually leaving the craft.
And so it's not, because the reason why I had my point of confusion is because in terms of the actual power output and thrust you would have some crazy 40 orders of magnitude difference between the electromagnetic coupling and the gravitational coupling between these things. And is this something that's understood, or is this something that
you lost me there? The 40 orders of magnitude.
Yeah, the conversion, the production of thrust, so far as I understand from the patents from Pais's patents, is it comes from the conversion of electromagnetic waves into gravitational waves via the Gertzenstein mechanism. And this is a small, very, very, very small effect, to the point that Pais needs his high energy electromagnetic field generator operating at the Schwinger limit, at an absolutely very high power level, to convert it into gravitational waves to produce the effect. And
maybe he's constrained by what physicists will understand, and I don't think it's really. you know, you really have to go to an ether model to think about this stuff, and maybe take some of these concepts like Schwinger limits and so on, and put them in the context of the ether to really understand.
I see, actually. No, and I was actually interested about this because I was unaware that they had measured Byfield Brown in vacuum, and that's where I was like, oh, like this is really cool that all of a sudden it's in vacuum. Because I would hear about it that it's like a wind effect, you know, from atmosphere and things.
Oh
like
no,
this,
it's not the ion effect at all. He's done vacuum chamber experiments and shown it's still there. In fact, it works better in vacuum.
Oh, nice. Okay, all right, yeah, thank you so much. Excellent talk, though. I appreciate it.
Oh.
Thank you.
Got a few more questions, Tim? I don't hear you.
Oh, I'm sorry. I'm sorry about that. Yeah. Yeah. Actually, I was just asking who else has questions.
I'd seen a few comments there, something about they didn't understand something about the piezoelectric.
You know, Marco had actually, he just put one through. He wondered about the Nasicus thruster. I'm not familiar with that.
Yeah, in fact, I think Dr. Nasicus is one of the attendants in actually, he should do a presentation at your conference.
Yeah,
and talk about his thrusters. Yeah, we're working together on that. His first version showed a very small thrust with a permanent magnet. But to get the big thrust, you need electromagnets, superconducting electromagnets. And we have a new version he's designed, which hopefully we could, I don't know, the computer model suggests enormous thrusts.
Yeah,
in terms of newtons, over 1,000 newtons, 100 kilograms, you know.
I think Marco had written here force to mass ratio of at least 13. So yeah, and
well, that was for the first version. You know, for these version, we're talking about thousands. You get one thruster, you can become Superman, go into space.
Oh,
if it works, we got to test it. You know, that's a project we're working on, getting requests for quotes and stuff for that.
Well, thank you. I've never heard of that one before, so I feel a little ignorant on that. But let me go to Jeremy next, sir.
I just have so many questions. Sorry, my mic was off. I had muted it for the live stream. I just want to remind all our live viewers that smash that like button and stay tuned, because it's going on. It's not the end of it. Paul, I wanted to ask a question about, you had mentioned in that first slide a couple things. I wanted you to talk more about black holes, what your idea was on some of your ideas on cosmology, and also what you said you can replace space-time with something else. And I was wondering, like, what do you replace quaternions with? And Minkowski space time metrics and that sort of stuff. Like, what was your replacement?
I replace them with model G. That's that partial differential equation set. That's the whole ball of wax. Very simple, just 3 partial differential equations. And it's a simulation approach. So, I mean, you can still retain all the physics observations. There's a lot of work to be done to intermingle what we developed over the centuries in physics with subquantum kinetics. So far, it's been me, and now we have a group doing the modeling. So there's no reason that anyone can just jump in and learn subquantum kinetics and start doing this work. One fellow has compared subquantum kinetics with standard physics and had all sorts of advantages of subquantum kinetics over standard physics in all sorts of areas. The simplicity is one. It's really quite elegant that you can get so much out of this one model, this approach. Whereas physics is more built like a patchwork quilt. My view I always talk about is that physics was developed by doing experiments, developing a theory about the experiment, and then you try to sew it together with other experiments into a unified field theory. And so the problem is you'll end up with a patchwork quilt. Whereas with subquantum kinetics, we begin with the genetic code, and we tweak the equations, pick the right constants and parameters in those equations that we simulate till we get things that match reality. As for black holes, they don't form at subquantum kinetics. For one thing, to form black holes, you have to have the gravity field within the particle go to infinity. It has to be a singularity. And that doesn't happen. And we see that in the actual particle scattering experiments, that the electric field doesn't go to a peak, it rounds off. And knowing that there's an electrogravitic connection, that would mean the same happens for the gravity field. So as two particles get closer together, the force goes to zero because their fields are plateauing. So the other thing is that when you have a collapse in subquantum kinetics, you would produce what's called genic energy, because in the supercritical region of a mass, energy is over unity. A photon increases its energy over time. Like on Earth, it's happening right now. And that's where the heat, the core of the Earth is coming from mainly. About 15% of the sun's energy is genic energy, spontaneously produced, the rest fusion. But as an object collapses, that genic energy depends both on the gravity potential, which would, the gravity well would go very deep as the object collapsed, plus the temperature would go sky high. And those two things together would cause genic energy to go through the roof. And that's why you get supernova explosions. It wouldn't be possible to form a black hole because the energy would be so powerful coming out, it would bring the collapse to a halt. You have what you call, I call them mother stars. They're supermassive cores of the centers of galaxies, and, like 4 million masses, solar masses packed in there, forming a star, immense mass star with an incredible energy generating capability. It's generating that energy over unity. It's photons increasing their energy over time. And it's an immense amount of energy that's radiated from those. And not only energy, but matter is created there. They're increasing their mass over time because matter created in the supercritical region gets blown out during the explosions. And 95%, 99% of the matter in our galaxy once originated from the core. So this is inside to out type of cosmology. Jeans had this idea, Sir Jeans.
How do you spell that?
James Jeans. As for cosmology, one of the first predictions of subquantum kinetics was that photons would lose energy as they traveled through intergalactic space, because intergalactic space should be subcritical. So just the opposite of what it is in the galaxy. And so you should get an exponential decrease. And so I started studying cosmology at that point, and I learned about the tired light model, and people were actually suggesting that just based on observation as an alternative for the expanding universe concept, that photons lose energy as they travel, and it's not really that the galaxies are receding. So I wrote a paper in Astrophysical Journal back in 1986, which showed that the compared the Big Bang theory, expanding universe theory, to the static universe tired light model, and the tired light model fit the data better on 4 different tests. And if you try to adjust the Big Bang theory to fit your data like they usually do on one test, then it would go further away from the data on the other test. So it's sort of like a Chinese handcuff. And so that pretty much put a nail in the coffin of the Big Bang theory. I've done an update of that paper, and I'm trying to get it published. And it's very hard to get published because everyone is so, in the physics community, it's sort of like become a religion. And anything, you can have the best paper and it won't get published. So you're going knocking door to door right now, hoping somebody will open. But you can see that paper, it's updated, and I now have 8 cosmology tests instead of 4. And so it's much, much better than what I published in '86 with updated data. And you can find it going to either starburstfound.org, to the archive, paper archive, or to the etheric.com archive. Also, there's a very good paper on gravity, which will be a chapter in a book on gravity coming out this year. And the paper is the pre-edited version, which is available for everyone. And it gives a very nice overview of subquantum kinetics, all the gravitational aspects of it.
Wonderful. Well, Paul, we're just about out of time for the Q&A session. We're actually going to go to Mike McCullough next. But again, let me thank you so much for spending the time to share all this with us and answer all the questions. So again, let me mute you back out, and I would put it on gallery view. And everyone, let's have, again, an enormous hand for Paul Laviolette. Sir, I cannot thank you enough. It was wonderful having you with us today. Thank you again.